like Einsteins in here. Woo! I don't even know why I need to bother to show up and teach. For real. I mean, you know it all. What's the domain, Jake? Hey, Jorge, are you done? Because I'm waiting on you.
X value, input, independent value.
No. Yeah, independent value. So, we have relations, all right, everybody? Relations are like your X and Y coordinate pair. This goes with this. This goes with this. Those are considered relations. We further define a relation as a function if our X value, which is our domain, is only assigned to one Y value. Okay, and you'll understand what I'm saying in a minute. All right, just know that it's called that a function occurs when each input or X value or domain, those are all the same names, has exactly one output value assigned to it. Okay, let's add that assigned to it. All right. So the domain is our X's, our input, our independent value. And the Y is our range, which is our output, which is our dependent. You know how, remember when we were doing proportional and we were saying Y equals KX, okay? And Y changed or varied last week in some of those, what did we do? Lord have mercy. No, it wasn't functions. It was what? It was, what is the last thing we did last week? I'm getting bad. Not system. Direct variation. Yeah. There we go. Direct variation. You know, and that's where as X changes, Y changes. It's because the X is the driving force, the independent value, and it changes like if X was charging you $40 per tire, then the total for 4 tires would be 4 times 40, which is, 4 times 4 plus a 0, 160. But if as X changed, if you were only going to buy 2 tires, then Y would change. And that's where we say the X is the independent variable and Y changes. It is the dependent variable based on what X is, okay? So that's what that means. And you'll get more involved in that in algebra, domain and range. But for our purposes, we just need it for this situation, which is functions and not functions. By the way, after today, in my classroom, at home, or anywhere on campus, I just want you to know you're allowed to use the F word.
Fraction.
No, the F word. Go up to Mr. Hanson and say, guess what, Miss Boyce told me I could use the F word.
The bad word? Why?
Alright? I dare you. Dare you. Go up to her and say, Miss Boyce said I can say the F word. And maybe I'll look at you like, but then he'll be thinking, I'm going to go get her, right? Guess what the word is? Function.
Man, no.
But see, you'll get him all nervous, and then you can go, function. Haha, gotcha.
Then you gotta get
You know what I mean? No, you won't. Not for that. No, you wouldn't. He'd like to know that you know a math term. I mean, I think he'd be pretty happy. Wow, they know a math word. That's good. Okay? Go home, tell your mom Miss Boyce said you could use the F word. Okay? Just make sure after her initial shock that you say the word function and not the other one, okay? Otherwise, Mr. Henson will get 75 phone calls from parents, but, pretty good.
Yeah.
If your mom has a good sense of humor, they might find it funny. Okay? I guess. All right, here we go. a mathematical situation, okay, when you have graphs and you have lines or dots on graphs. And the way you tell whether a graph is a function or not is you use something called a vertical line test. And a vertical line test on a graph is where you take the edge of a piece of paper, a ruler, you can even draw lines on your paper, and you're trying to see if you touch more than one point or more than one place on the line that is drawn or on the graph in more than one place at the same time. Okay, and let me show you this. So I got a ruler. Okay, I'll just use a piece of paper because that's all you guys have, or you can always use your pencil. Okay, and what I'm doing is I'm looking and I'm taking, if I was to use a piece of paper and I was to start on this left-hand side of the graph, vertical is up and down. And so I'm going to slowly pull this piece of paper to the right. Okay, I see a point. Do you see a point? But do you see more than one point? No, you only see one, correct? How about I'm going, I see a point, but I only see one. Okay, I see a point. So this edge here is only touching 1 point so far at the same time. 1 point, 1 point, 1 point, 1 point. Therefore, since I did not touch more than 1 point at the same time with the edge of my paper, it is a function. And I'm just going to use F for function, right? Now, this is a line drawn on the graph, and I'm going to highlight it by putting it in orange, okay? I'm going to do the same thing. If I touch that line with the edge of my paper in more than one place at the same time, it is not a function. So here I go. I just come across. Have I touched more than one place on that orange line at the same time? No. So therefore, it is a function. Okay? Let's try this one. I'm going to draw it orange just because it kind of highlights it and it makes it easy to pick out. Okay? So I take my edge of my paper. I start here, and I'm so far only 1 point on the line. Uh-oh. Now, how many places am I touching that line that's drawn in orange? 3, actually, right? Here, here, and here, which then means it is not a function. And what we're really finding out is that the x value of all the points where I touched it at the same place, the x value or the domain would have been, I would have had a 1, 2, I would have had a negative. A negative 1, maybe, let's just call it negative 1, 0 for the fun of it. And then this one is a negative 1 and negative 2. If you notice, I have the same x value. And that is why it is not a function. Your domain cannot be repeated. Okay? That's one way that you're going to have to be able to state whether it's a function or not. Your range can have the same number all day long. In other words, I could have, my range could have been negative 1, 2, negative 1, 2, or negative 1, 2, 1, 2, and 2, 2, and it would still be a function because if you look at that at a graph, here's 1, 2, and 3. Let's just say it's that. And here's 1 and 2 on my graph. Let's say I have a dot here, I have a dot here, and I have a dot here. I've got 1 and 2. I have 2 and 2. I have 3 and 2. My domains or my x's are all different, but my y's are the same, aren't they? My ranges. If I take my piece of paper, do I ever touch more than one of those dots at the same time? No. And so therefore it is a function. It doesn't matter if your range is repeated. It's your x that cannot. Another way you're going to see things is mapping. Okay? Let's just kind of ignore this for a second, and we're going to go to that on the second page. Mapping is when you have these ovals or you have this box. And domain, or remember in a table, I told you the X's are always on the left and the Y's are always on the right. Okay? So that is your domain, which is your X values. The easiest way to do this is to take your hand, you cover your ranges, okay? And if you notice, I've got one line coming out of -3. How many lines do I have coming out of -2? 2. That means that it's not a function. I can only have one line coming from each X in order to be a function. If I wrote these pairs out, it would be -3, -3. It would be 2 and -1 because 2 is mapped to -1. 2 is also mapped to 4. And then I have 4 and 3. Do you see if I circle my X values, do I have a repeated X? Yes. Do you see how 2 is repeated? That is accounting for those 2 lines coming out. To be a function, my X value cannot be repeated. Okay? So this is not a function. So, like I said before, the easiest way to do this, look at this. I've got X's on the left, Y's on the right. Take your hand, cover the Y values, look at the X's. How many lines are coming from each X? 1, and 1 only. Okay? That means that it is a function. Okay? Do it on the last one for yourself. Put your hand on it. Determine whether you think it's a function or not. How many say function? How many say not a function? Why is it not a function? You got 2 lines coming out of -4. So this is simple. This is simple stuff, people, okay? All right, flip the page. This is the third way that you will see functions, okay, is this way. Now, when you see mapping, think of that as a table, okay, because you might see it in a table too, all right? But just, it's the same premise. You need to have your X's not repeated. Here we go. In pairs, it says circle the domain, which is what value? The X's or the Y's? X's, okay? And state whether each relation is a function. So I'm going to come over here. I'm going to circle all my X's. Okay? I have a 3, an 8, a 9, a 3, and a -4. Is it a function? No, because what repeated? 3. So NF, not a function. Okay? I'm not even making you write the word out. All right? What about over here? Circle your X's. Do I have a repeater? What's my repeater? No, it's not. That says 6.5. This says 6. Do I have a repeater? No. So is it a function? Yes. What if I had -6 and 6? Would it be a function? Yes, because remember, -6 is a different number than +6. Okay? So let's try these. All right? Okay. Min. This one. What are you going to do to figure out whether it's function or not? Put your finger on the right side and then, is it a function? Why? Because there's only one line coming out from each X. Okay? These are your X's, these are your Y's. He says, yes, he's correct. It is a function. Okay? right. Josue, what about number 2? What am I going to do? It's a non-function. Why? It's not a function. Why? Because 2 lines are coming out of 3. Do you see that, everybody? Okay, so not a function. All right. What am I going to do on number 3? Yes. So let's just get in the habit. When we have pairs, we circle the X's. Okay? If you circle them and say them, you'll remember whether you repeated it or not. Did you repeat it? So is it a function? Okay. Miguel, what about 4? What am I going to do? Circle the X's. That would be what numbers?
4, -2,
Is it a function?
Yeah.
Okay. Ambria, number 5. What am I going to do? Is it a function? No, because it's repeating. That's correct. Okay. All right. Jamarian, what am I going to do on number 6? Circle the X's. Do you have them done already? You're almost sleeping. What's that in your mouth? Oh, okay. Is that like your pacifier? No? Okay. All right. Is it a function? Yes. Because that's not repeating. Right. Okay. All right. Number 7. Jorge, what are you going to do?
You gotta
Circle what? Circle the X's?
yeah,
Okay. Circle the X's, and then what? Is it a function?
no. Oh yes.
Yes, because
You're repeating numbers.
that's correct. Okay. All right, Mason, what am I going to do on this graph? How am I going to figure out whether it's a function or not?
Wait, what's number 7?
It's a function. What am I going to do? Do you remember something about this? Uh-huh. And if I touch what? More than one spot on the line at the same time, it's not a function. Was it a function? Yes, it was a function. Okay. All right, Monty, what about this one? Okay, am I touching more than one spot on the lines? So is it a function? No. Okay. All right. This, I want to show one thing off before we move on, because it's some of the students in the last period kind of struggled with it. When you're looking at a graph, okay, don't get off, just take your paper or take your pencil. If you touch more than one place at the same time, it is not a function. If you don't, then it is a function, okay? All right. It looks like a lot, but it takes you like 5 minutes to do these, okay? Believe me. This should be the easiest thing. We have a review on the back table. If you finish this, I would suggest that you start the review. Tomorrow you will again be working on the review. You have an assessment that will be Thursday and Friday. It is going to be 19 questions. It will cover everything from the beginning of school until now, which we've been spiraling all along. You've had a math question on every test, haven't you? Pretty much an order and compare on every test. So, but it's going to have that wonderful thing called slope again that most of you hate. Remember, that's why doing the review, asking questions will be very helpful. So I want to make sure you have time to do both. So I would start it today if you finish this. On this paper it says, circle the domains and state whether each set of ordered pairs is a function or not. You don't have to write out function. All you have to do is tell me F or NF. Not a function or a function, okay?
I just put L.
Or you could use net, yes or no, but okay. And this practice will go really quick. Please, if you have questions, ask, because this is the only day we're going over functions.